Welcome to Subnetting Level 5, using subnet masks to assign IP addresses to LANs. Let's take a look at Company ABC. Company ABC operates its business out of two buildings that are next to one another. In this simplified example, we see that Building 1 has one local area network and is using the IP address range of 192.168.20.0. When the IT network administrator assigns IP addresses to PCs in the Building 1 LAN, the network portion of the IP address is the same for every device. In this example, every device in Building 1 will have the same number in the first three octets. These values are 192.168.20. The fourth octet is reserved for the host portion, which will give that device a unique IP address. For example, the PCs in the diagram have been assigned 192.168.20.1, 192.168.20.2, and 192.168.20.3. Let's shift our focus to Building 2. The LAN has been assigned the IP address range of 192.168.50.0. Building 2's PCs have been assigned 192.168.50.1, 192.168.50.2, and 192.168.50.3. So how do these networks communicate with one another? A router is required to route information between two LANs. The router, of course, is not a plug-and-play device. It needs to be configured. One very important configuration is that of the subnet mask. We are going to talk about the subnet mask next. A subnet mask works with the IP address to identify what portion of the IP address remains constant to identify the network and what portion of the IP address can be changed for each host. Let's start out by talking about the most common subnet. It is referred to as the /24 subnet mask, also known as the Class C subnet mask. In dotted decimal, it looks like this: 255.255.255.0. In binary format, it contains 24 ones and 8 zeros. If you don't believe me, we can count the bits. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. The 1 bits indicate the network portion, and the 0 bits denote the host portion. /24 gets its name because there are 24 network bits. Okay, so that's a lot to take in. Let's apply the subnet mask to see how it defines what IPs are in a network. Because the first three octets of the subnet mask are all binary ones, 255 in decimal, every IP address in this network must begin with 10.40.5. The only octet that can change is the fourth octet. That value always begins with 0 and ends with the largest value of 255. Devices in this network must have one of these IP addresses. The list here is abbreviated because there isn't enough room to list every IP address from 0 to 255. If we take a look at our previous example, the correct way of displaying the network IP would be to include the /24 notation after the first IP address in the range. Now let's take a look at another subnet mask. The /16 subnet mask is also called the Class B subnet mask. In a /16 network, the first two octets remain constant to identify the network, and the last two octets can be changed for each host in the network. In dotted decimal format, it looks like this: 255.255.0.0. In binary format, it contains 16 ones and 16 0 bits. The 1 bits indicate the network portion, and the 0 bits denote the host portion of the IP address. /16 gets its name because there are 16 network bits. Let's apply the /16 subnet mask to see how it defines what IPs are in its network. Because the first two octets of the subnet masks are all ones, 255 in decimal, every IP address in this network must begin with 10.255. The third and fourth octets can be assigned combinations of the values 0 through 255. In a /16 network, the third and fourth octets begin as 0.0 and ends with the last IP address, 255.255. Believe it or not, if I listed every IP address in this network, there would be over 65,000 IP addresses. Different LANs can support a different number of hosts. The subnet mask determines how many IP addresses can be used in a network. For example, a /24 network has 254 host IPs available. A /16 network has 65,534 host IPs available. If you look at the PCs in Building 1, you will see that they have been assigned IP addresses within 10.40.5.0/24. If you look in the PCs in Building 2 LAN, you will see that they have been assigned IPs within the 10.25.0.0/16 network. Yep, it's time to practice. Identify which IPs are available in the 192.168.8.0/24 network. Here's a hint. The dotted decimal subnet mask is 255.255.255.0. That means that in order to be in this network, the IP address must start with 192.168.8. Feel free to pause the video, grab some scratch paper if needed, jot down your answers, and resume the video when you are ready to compare your answers to mine. Okay, here are my answers. The first two IP addresses are part of that /24 network. The next two are not. One has a 186 instead of a 168 in the second octet, and the other has a 191 instead of a 192 in the first octet. The next IP address is in the network. The one after is not. Why? Because you cannot have a number greater than 255. Remember? The value 256 doesn't make any sense in an IP address. Okay, agreed. That one was a little tricky. The last IP address is in the network. All right, more practice. Now let's identify which IPs are available in the 172.16.0.0/16 network. Again, here's a hint. The dotted decimal subnet mask is 255.255.0.0. That means that in order to be in this network, the IP address must start with 172.16. Ready, set, pause the video. When you return, I will reveal the answers. Okay, here are the answers. There are 3 IP addresses that are not part of the /16 network. The reason is that in all 3 of those IPs, the second octet is a different number than 16. Good work. That completes level 5. Amazing effort.